Hello everyone, this is Avnish. Today my research topic is facial recognition technologies everywhere you look, a deep dive into privacy concern. In this presentation, I will explore the growing use of facial recognition technologies and its significant impact on individual privacy. I will discuss the technical aspects and rising concern regarding the potentials to infringe upon our right to privacy. So let me start with abstract. Facial recognition technologies is rapidly advancing and finding application in various fields, but its widespread use raises a significant privacy concern. We'll discuss all these privacy concerns in detail in the upcoming slides. This presentation also explores the technical aspect of facial recognition technologies, as known as FRT, analyze its potential for privacy breaches, and proposes a solution to mitigate these risks. Let's start with the introduction. Facial recognition technology is a sophisticated system that can identify or verify a person's identity by analyzing their facial feature. It works by extracting unique characteristics from the person's face, such as distance between their eyes, the shape of their jawline, and the prominence of their cheekbones. These extracted features are then compared to a database of known individuals to determine the image. It involves a complex algorithm and powerful computers to analyze images and videos. So I am going to explain the technical analysis in terms of computer vision, machine learning, biometrics, and technical aspect of privacy concern. Facial recognition technologies relies on algorithms to analyze facial features and compare them against a database. Common approaches include like eigenfaces, local binary patterns, and deep learning, and neural network. Let's understand one by one. So let's understand the first one, computer vision. Uh, so Imagine facial recognition technologies as a detective trying to solve a case based on a photo. Just like a detective needs a clear picture, facial recognition technologies also needs a clean image for accurate analysis. To provide a clean image, and then what we need to do? We need to do pre-processing, and pre-processing is like taking a photo to a photo lab for enhancement. This steps involves like noise reduction, contrast enhancement, and by cleaning up these images, we ensure that facial recognition technology system has better chance of accurately identifying the individuals. Now there are two types of feature extraction, like identify potential facial regions like VJ object detection framework and CNN, which is known as convolution neural network. It's more advanced approach that learns to identify facial features directly from image data. Second one is machine learning. Machine learning plays a critical role in facial recognition technology in terms of principal component analysis and eigenfaces and similarity matching algorithm. Let's understand what is principal component analysis help in facial recognition technologies. So PCA reduces the data complexity by identifying the most significant feature from the extracted facial data, and PCA helps organize the information by identifying the most important characteristics like eye distances, cheekbone shape, etc. Whereas eigenfaces capture the variation in these key features, forming a compressed representation of face for efficient recognition. Think of eigenfaces as sketches, and PCA extract the key feature and create a simplified representation of a face, similar to how a sketch captures the essence of person's features. These eigenfaces as a compressed code that the system can use for comparison and so that we can process large amount of image data as it is compressed. By using PCA and eigenfaces, the system can efficiently analyze large amount of facial data and perform recognition task. Let's understand the similarity matching algorithm. There are two types of similarity matching algorithm at a high level. One is Euclidean distance and another is cosine similarity. Euclidean distance, imagine placing the sketch on the top of each suspect photo in the file. The distance between the sketch and the actual facial features determine how well they match. A smaller distance suggests a closer match. As it's defined, Euclidean distance measures the straight line distance between the unknown face feature and those of stored faces in the database. So basically, it's a comparison between the whatever the face you have and whatever the face in the database. Whereas cosine similarity, consider the angle between the feature vectors of the unknown face and stored face. A higher cosine similarity value suggests a greater resemblance. This method considers the overall similarity in the direction of facial feature, and these algorithms efficiently compare the unknown face against a vast database to find the closest match. So third one is biometrics, which includes two techniques at a very high level: facial landmark detection and liveness detection. Facial landmark detection locates specific facial points for accurate representation, whereas liveness detection distinguishes real individual from attempt to spoof the system. Let's understand with an example. Imagine the detective has a blurry photo of a suspect, but they also have a detailed witness report mentioning a scar above the right eye. Here, the facial landmark detection will help. How does it help? So, facial landmark detection goes a step further than a basic feature extraction, and this process acts like a witness report, providing additional details by pinpointing specific facial points like in the eyes, nose, mouth with greater precision. By analyzing these relative positions and distances between these landmarks, the system can create a more accurate representation of the face. Whereas the liveness detection needs to ensure it's dealing with the real person, not a photograph or someone trying to impersonate another individuals. Liveness detection techniques are like advanced interrogation methods like blink detection, depth sensing, facial expression analysis. By incorporating these methods, facial recognition technologies system become more robust and less susceptible to spoofing attempts. So fourth one is privacy concern. There are three types of privacy concern we can think of, like data collection and storage, beyond identification, liveness detection that we explained earlier slide. Let's understand this with an example. Imagine a world where your face is constantly being monitored and recorded in a public places without your knowledge or consent. This is a reality with widespread facial recognition technology uses. Data collection in public spaces raises concern about excessive surveillance. Just like everyone deserves the right to privacy in their home, they should also have a reasonable expectation of privacy in public areas. Data breaches are major risk. Be mindful that the data collected for one purpose might be used for that purpose. Facial recognition technologies goes beyond simply identifying individuals. It can potentially extract a wealth of additional information, raising a privacy concern. Analyzing facial expression to infer emotions could be used for targeted advertisement or social manipulation. Tracking individuals based on their political affiliations could have a chilling effect of freedom or of expression and assembly. So let's understand the image captured, what format they are stored, and what are the security measures. So image formats could be JPG, PNG, compressed file, and it could be uncompressed raw file. Resolution and color depth. High resolution and color depth require more storage but enable better recognition. facial templates, compressed representation containing key features used for identification. Feature extraction method we explained in earlier slides like eigenfaces, local binary, deep learning based methods. It's used for high accuracy. Whereas the security measures includes encryption, access control, anonymizations. So let's understand the security vulnerabilities and misuse. How can the data be misused? So facial data breaches can have severe consequences. Like sensitive biometric information, facial templates is highly valuable for criminals. A data breach could lead to large scale identity theft, financial fraud, and other malicious activities. Let's understand with an example. Imagine someone is stealing a key of your house. Facial data breaches are similar to that. If not a secure, criminal can gain access to this sensitive information and use it to impersonate individuals, steal their identities, and commit crimes. As most of you are aware about the deepfakes, it's so popular that deepfakes are realistic looking videos or audios recording that have been manipulated using artificial intelligence to make it appear as if a person is saying or doing something they never did it. Synthetic identities can be created using deepfakes or other AI techniques to impersonate real people. Deepfake pose a significant threat to the trustworthiness of information and can be used to spread misinformation, damage anyone's reputation, or manipulate public opinion. Data retention policies. So we should minimize data retentions, define clear retention periods like a number of days, regulate regular data deletion. We should delete data every once in a month or once in a 15 days like that. Transparency. Inform individual about the data collection practice and how long their data will be retained. Extensive surveillance. Individual movements and activities can be constantly tracked, raising concern about a loss of privacy. Here are the solutions and the recommendations. So, informed consent. When you are collecting a data from any individuals, we should require companies to obtain a consent before collecting the facial data. Data minimization. Collect only the minimum data necessary. Whatever is unnecessary, we should collect only that data instead of every person we need to include. Anonymization and encryption. Protect the data through anonymization and encryption techniques. Algorithm audits. Conduct independent audit to identify potential bias in algorithms. Disclosure. Companies using facial recognition technologies systems should disclose their functionality and data collection practices. Diverse training data set. Develop facial recognition technology system trained on diverse data set to reduce biasness. Explainable AI, as known as XAI, implement XAI techniques for better understanding of decision-making process. And encryption. Encrypt facial data at rest and in transit. These are the these are all our solution and the recommendation I could think of. That's it. That's it. I hope you had a great learning with the facial recognition technologies, a deep dive into privacy concern. Let me know if you have any questions. Thank you so much.